Welcome to Math Proofs. I'm your host Adioja, and today we're going to prove that a plus b, the whole thing squared, is equal to a squared plus b squared plus 2ab. And it's worth understanding that a lot of us have this misconception, myself included, that a plus b squared should be equal to a squared plus b squared. I mean, it just kind of makes it simple, right? A plus b squared, well, that has to be the same thing as a squared plus b squared. So why am I adding this plus 2ab to the side? That is the question. So let's explore this example first using some numbers. What if we had 3 plus 4 squared? Would that be equal to 3 squared plus 4 squared? Well, let's see. 3 plus 4 is 7. 7 squared would have to equal 3 squared, which is 9, plus 4 squared, which is 16. 7 squared is 49. And that definitely does not equal 9 plus 16, which would be 25. So it appears that for some reason, even though it seems intuitive, a plus b squared is not the same thing as a squared plus b squared. And throughout this proof, I hope to show you why this is the case. So before we begin, let me clear up my board and let us start. Okay, let's start with our main idea here. So we know that we want to get this term, and that is a plus b squared. And I'm going to represent this visually by actually drawing a very large square. So this is going to be our square. So let's say that if this was our square, I'm going to make each side of the square have a value of a plus b. So that's its width, and that's its length. Or flip that. This is its length, this is its width. So what would the area of this square be? What would the area be? Well, it would be length times width. A plus b times a plus b. Or as we like to say, a plus b squared. So that is the area of this square. Now what I'm going to do is I'm going to say that this value is equal to some stuff in here. So I'm going to draw some shapes in here, and hopefully we'll get some equation. So because this whole side length is a plus b, that means that there's a portion that has a value of a, and another portion that has a value of b. So let me draw some interesting shapes in here. I'm going to draw a square within here, in which both side lengths are a. What would be the area of this square? You guessed it, a times a, or a squared. So over here we'll put a squared. Now what else do we have? Maybe you can see that we can draw another square here. Because from here to here has a length of b. If we just move that line up over here, we'll have a length of b. Same thing over here. So the area over here will be b squared. So over here we have a b squared. Now notice, this whole area, this whole square, has an area of a plus b squared. But a squared and b squared only take up a small portion. We have just covered this area so far. We have yet to include these two rectangles, which I will label with an R. We're forgetting about them, and that's where we're going to get our second term. Now understand that, let me just erase those R's for a second, that this side length over here is a, because this is a square. So the area of this rectangle will be length times width, AB. Same thing over here. This has a side length of A, this has a length of B, so the area of this rectangle is A times B. So now we have two A times B's. Now we have covered this portion. Now we have covered the whole square. I'm going to erase those marks just for clarity. But now you see that we have covered this whole area. So we're just going to tidy up our equation. We have a plus b squared, which is again the area of this whole square. That's the same thing as this small part over here, a squared, this bigger part over here, b squared, and these two parts, 2ab, these two rectangles. And we're done. We see that we have this simple equation, and we can see that we got it by thinking about an actual square whose side lengths were a plus b. And I hope you can now see visually why a squared and b squared aren't enough. They're just these two sections. We were completely disregarding these rectangular sections. This has been a Math Proofs video. My name is Adi Oja, signing off for today.